विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ।
Hello listeners, you're listening to Vigyan Ki Awaaz podcast program on STEM popularization, catalyzed and supported by the Ministry of Science and Technology, Government of India and Media for Community Foundation. Project devised and designed by Dr. R. Sridhar and assisted by Ashish Tiwari. Local coordination and production, Professor Subramanian. Content writing by Priyanshu and post-production by Professor Kaushik P. Kanchan of Garden City University, Bengaluru.
Garden City University, conquer we shall all adversity. GCU, emphasis on life. GCU, emphasis on life.
You understand? So I need to now worry about how to make it stable at room temperature. So my research revolves around that. How to make it stable at room temperature. Not just at room temperature, I should make it work even at sub-ambient temperature, below the room temperature, and some range of temperatures above also. See, you are all using the liquid crystal displays in your mobile phones or anywhere in your smartwatches. So this materials, liquid crystals, the phase that I am working also is exhibited by a liquid crystal. This particular one. But the one which you are using in your mobile phones, not you are using, the mobile phones that you are using has this liquid crystal in another type of phase called pneumatic phase, pneumatic liquid crystal. So they prepared this material, hundreds of years of research has gone into this to prepare this particular pneumatic liquid crystal which works for you whether you are in Bangalore or whether you are in Sahara Desert or you are in Himalayas. Your watch should work, no?
Don't have the temperature of that.
Because this particular material in that particular phase, it works in all these temperatures. Whereas I am going behind a particular phase that I am talking about, the liquid crystalline phase, which is very unstable as of now. We are doing different types of research to make it, stable over this range of temperature. The same temperature as how the pneumatic liquid crystal is working, so that I can use it for so many applications. For example, you can make tunable laser, you just apply an electric field and you can change the colors of this material, how it reflects. You can change right from blue to all the way to red. The entire visible spectrum you can vary. But I need a stable material to do all this. It has fantastic properties. It can be used in photonic devices, all that we can do. But I need to stabilize it. So I do this work mostly right now. That is what is going on. Apart from many other things that's going on. So. Yeah, short term, in terms of short term as of now, to be honest, like this research is not just happening in India, it's globally people are working on it. So we are actually also in that field. It's not like only one group works on it, right? So if you want to talk about short term goals, then there are certain fundamental aspects of this is still not understood. When I said a blue phase liquid crystal, there are 3 different types in it. Blue phase 1, blue phase 2, blue phase 3, like that. And a particular blue phase just doesn't get stabilized. You do whatever you want. And it's so difficult to understand why it is not getting stabilized. So you may be able to answer some of the fundamental questions, which is like a short-term goal. Also, students who are working in this field, they get trained to understand all this. That's another goal. You need to. For example, I actually am a superannuated scientist here. I'm not on a permanent role in that way. So, but I have trained students who will be taking this forward. So there is a manpower training, the fundamental aspects, And we also prepared small prototype devices, and we show it in our gallery. And if there are anybody who is interested, because we also do patenting, these are all some of the short-term goals. And if anybody is interested, they can come and talk to us and take it forward, if they give the funding and things like that. That's the short-term goal. The long-term goal, of course, it's an extension of this, I would say, that it needs a lot more research to come to a stage where the pneumatic crystal, which is available everywhere, and it's so cheap, but this particular one, for that to happen, it will take another 50 or 100 years, if at all. So it's not like it can happen today. So not the consistency, the development, the research and the development that is happening will take that. So the long-term goal is that if this material works, then it can be used in, now what you have is the electronic integrated devices you have, right? So that's all based on the electrical inputs or whatever. But with this kind of a photonic materials, you can think about devices that work with light as the input, which will be much faster. So in terms of the long term, like all this quantum computing and all that, this photonic integrated circuits, which is based on such photonic crystals, will be the long term. The long term should not be more than, these days it's all much faster. It's not like 100 years. It should be happen in 20, couple of decades.
You were listening to Vigyan Ki Awaaz, a podcast on STEM popularization, catalyzed and supported by National Council for Science and Technology Communication, Government of India. Tune in for more such episodes to Vigyan Ki Awaaz on this platform and also through Spotify, YouTube and Apple Music platforms.
आइए हम सुने विज्ञान की अनकही कहानियां।